Hey, my name is Rejo Raju. I'm in the Aerodynamics class and I'm going to be doing my airfoil project. I'm going to be talking through it as I do it. Behind me, you can actually see my Excel and Word that I've already done, but I'll show you how I did that. I'll go through that. First we did is Naga 0015. Pulls that up. Then we can do paint to smooth it out. Here, there you can see it. I'll move that over here. Oh. We change our N to about, I'm going to do 450. T is 1. That should be good there. Then we're going to do opper. It's inviscid, so we have to put a vis. About 1 million. And then your iterations, I'm going to change to 1,000. Here, then to put it into a file, we do PACC. And I named mine, this was NACA NACA 0015. I put my initials, and for the video, I'm going to put vid, so there'll be two different files. Then I can do S, actually A sec. I'm going to do -5 from, I'm going to do -5 to 15 with iterations of 1. There you go. And then if you come here and look at, let's see, UCF Aerodynamics, Xfoil dot, this is the one, dot the vid, notepad, you can see it's all in there. Now that's for NACA 15. I've had issues just going from the same window, from the same command window, so I usually close it out and I open it again. So Aerodynamics, Xfoil, open Xfoil. Now we're going to do NACA 2415. Let me just make sure that's correct. 2415, right? Yeah. Enter. Again, we smooth it out. That's what it looks like. And 450 is 1. From here, operations. Again, viscous 1 million. Iterations, we're going to do 1,000. PACC here. NACA 2415. My initials, and then this is for the video. Here I can do A SEQ, again from -5 to 15 iterations of 1. It's tabulating. Since I did 1,000 iterations, it takes a little bit, a few seconds. I should probably drop down the iterations just for the video, so it won't take as long. But I did notice that when I go on to the Clark W airfoil, I do need 1,000 iterations. Otherwise, it's kind of finicky and doesn't converge. Speeds up a little bit. There you go. There you go. Again, if I come here, .vid. This was at 2415 notepad. You can see it's all there. Finally, this is the fun part where we have to upload an airfoil to Xfoil. Aerodynamics, Xfoil. So where we do load CLARC .txt. Clark W. What did I name it? Clark W.txt. Yeah, Clark W.txt. I guess I should also mention I fixed this to go from 1 0 all the way back to 1 0, so I give that and all the way around. Move that here. Here, once I've done that, and paint R, and I do 450. T is 1. Upper viscous. Change that to 1,000. 1 million. Sorry. Iterations is 1,000. Pack. I will do CLAR Clark W. I'll do my initial, and then for the video, then I can do a sec again -5 to 15. I really hope this works. Okay, that's awesome. Yeah, it's working. Again, it takes a few minutes only because of the 1,000 iterations. But like I mentioned before, I had to get my nodes, number of nodes, and my iterations to 450 and 1,000. And I tried a bunch of other ones, but they weren't converging, and I was having issues. So this seems to be working. So yeah, I'll just let it do its work. Thank you. That's it. As you can see here, you can see everything here, and it also has been pasted to, or the data has been exported to, it will be Clark WRR vid. If I open a notepad, you can see everything is there. So from there, I uploaded each of that. Here is the first one for NACA 15, so you can see here. Then here is the next one for NACA 2415. Here's the next one for the Clark W airfoil. Here you can see the coefficient of lift versus alpha, or the angle of attack, the coefficient of drag versus alpha, and coefficient of lift divided by coefficient of drag versus alpha, or the angle of attack. These are the three graphs. I had to do a smaller points to get the slope correctly to go through them. It's about 0.11. Here's the minimum drag coefficient for each of those graphs or charts, and here's the max seal value.